Dear students, in this section, we are going to do some problems related with the equation of continuity. The first one, water is flowing in a pipe with a varying cross-sectional area. At a point 1, the cross-sectional area of the pipe is 0.05 meter square and the magnitude of the fluid velocity is 4 meter per second. The questions are, what are the fluid speed at points in the pipe where the cross-sectional area is 0.15 meter square and 0.05 meter square. Also calculate the volume of water discharged from the open end of the pipe in 1 hour. You can read the question once more. Okay. Here we have a non-uniform area cross-sectional pipe, and at the point 1 we are given the area cross-section and the fluid velocity. So let us write at the point 1, that is A1 is equal to 0.075 meter square. At that point, the velocity, fluid velocity V1 is equal to 4 meter per second. And we are asked to find the fluid velocity at the two sections, at the point 2 and 3. So we can use the formula, the equation of continuity. So at the section, at the point 2, the area of cross section let me denoted by A2. A2 is equal to 0.15 meter square, and A3 is equal to at the point 3, and the area cross section is 0.05 meter square. Okay, then we can use the equation of continuity. So let us consider the 2 points 1 and 2. Here we can apply the equation of continuity, that is A1 V1 is equal to A2 V2. So from that we can have the fluid velocity at the second point, that is V2 is equal to A1 V1 divided by A2. So let us substitute 0.075. V1 is equal to 4 meter per second, and the area cross section the second point is 0.15. So after the calculation, you will get the velocity at the second point is 2 meter per second. Okay, similarly, we can also find the velocity at the section at the point 3, like this. That is, again using the equation of continuity, A1 V1 is equal to A3 V3. From that, V3 is equal to A1 V1 divided by A3. So let us substitute 0.075 into 4 or divided by 0.05. So after the calculation, you will get the velocity at the third point is 6 meter per second. Okay. Now, the third question is, calculate the volume of water discharged from the open end of the pipe in 1 hour. We know the volume flow rate. The volume flow rate, that is the product of, that is equal to the product of area and area cross section and velocity. That is A into V is a constant. That constant is the the volume flow rate, that is the volume of the water flowing in 1 second. So let us write the volume flow rate, that is equal to the area cross section into velocity, that is A into V. So here let us substitute, let us take the values at the point A1 and V1. So volume flow rate is equal to A1, and that is the volume flowing out in 1 second. So therefore, the volume of water flowing in 1 hour is equal to A1 into V1 into what is the how much second is the 1 hour? That is 3600. So let us substitute. What is A1? That is 0.075 into velocity for V1 4 into 3600. So after the calculation, you will get 1080 meter cube. 1080 meter cube. This is the volume of water flowing out in 1 hour. Okay. Now move to the second problem. Water is flowing in a pipe with a circular cross section, but with a varying cross section area. So question A, at one point in the pipe, the radius is 6 centimeter. What is the speed of the water at this point if the water is flowing into this pipe at a steady rate of 1.2 meter cube per second? Question 2, second question, that is at a second point in the pipe, the water speed is 3.5 meter per second. What is the radius of the pipe at this point? So let us do this problem. You can read it once more. Again, we have a pipe with a varying cross-sectional area. So you can take this. This is the, let us take this is the first point, and this is taken as the second point. So at this first one, you can have the area cross-section A1 and velocity is taken as V1. Here also area cross-section A2, velocity is V2, and you can also consider this is the radius is here R2, and here the radius is R1. Okay, again we are going to use the equation of continuity. So we know the flow rate. We are already given the flow rate. So the volume flow rate, we know it is equal to A into V, area into area cross section into velocity. Okay, and this value is already given. That is 1.2 meter cube per second. That is the volume of liquid flowing out in 1 second. That is the volume flow rate. Okay, and let us consider the first point. So at the first point, what is the radius? The radius is given 6 centimeter. So that is R1 is equal to 6 centimeter. That is equal to, let us convert it to meter. That is 6 into 10 raised to -2 meter. And let us substitute in the above equation, that is A1 V1 is equal to 1.2 in. Okay. So what is A1? A1 is the area cross section at the point 1. So that is pi r1 square v1 is equal to 1.2. Okay. Therefore, v1 equal to 1.2 divided by pi r1 square. So let us substitute 1.2 divided by 3.14 into the radius is 6 into 10 raised to negative 2 square. So after the calculation, you can find the velocity at the first point is 106.16 meter per second. You can do the same method for finding the velocity at the second point. So at the second point, so v2 is equal to 3.5 meter per second. Okay. So again, substitute again using the formula A2, the product of area cross section velocity equal to the flow rate. So A2 V2 equal to 1.2. Therefore, pi R2 square into V2 is equal to 1.2. Therefore, R2 is equal to square root of 1.2 divided by pi into V2. That is 3.14 into V2 pi into V2. Let's substitute again. That is square root of 1.2 divided by 3.14 into 3.5. So after the calculation, you can find that the radius at the second point is 0.33 meter. 0.33 meter. Okay. Now the third one. A shower head has 25 circular openings, each with a radius of 1.5 millimeter. The shower head is connected to a pipe with a radius of 1 centimeter. If the speed of water in the pipe is 5 meter per second, what is its speed? The speed as it exits the shower head openings. ഒരു ഷവർ ഹെഡ് പൈപ്പിൽ കൂടെ ആ ഷവർ ഹെഡിലേക്ക് വാട്ടർ വരാണ്. അപ്പോൾ ആ ഷവർ ഹെഡിന് 25 ഓപ്പണിംഗും വളരെ ചെറിയ ഓപ്പണിങ്സ് ഉണ്ട്. ഓരോന്നിന്റെയും റേഡിയസ് 1.5 മില്ലിമീറ്റർ ആണ്. ഓക്കെ. പിന്നെ ആ ഷവർ ഹെഡിലേക്ക് വരുന്ന പൈപ്പിന്റെ റേഡിയസ് 1 സെന്റിമീറ്റർ ആണ്. അതുപോലെ ആ പൈപ്പിലെ വെലോസിറ്റിയും 5 മീറ്റർ പെർ സെക്കൻഡ്. അങ്ങനെയാണെങ്കിൽ ആ ഓപ്പണിംഗിൽ കൂടി പുറത്തു വരുന്ന വാട്ടറിന്റെ വെലോസിറ്റി എത്രയായിരിക്കും? So again we can use the formula, the equation of continuity, that is A1 V1 is equal to A2 V2. A1 V1 is equal to A2 V2. Okay. So we have a here we have a very small openings there. Here the 25 small openings are there. Okay. So let us consider here is the area cross section of the service point here V1, A1 and V1 is the velocity at this pipe, and through this for the very narrow opening the area cross section is taken as the A2 and total area cross section is A2 and the velocity at this opening is V2. So by using the equation of continuity, A1 V1 equal to A2 V2. Okay. here we have the value of A1. A1 is equal to A1 നോക്കൂ the പൈപ്പിന്റെ ഏരിയ ക്രോസ് സെക്ഷൻ ആണ്. that is pi r1 square. that is equal to, let us pi, what is r1? 1 centimeter. When it's converted into meter, 1 into 10 raised to, so 10 raised to minus 2 square. So that is A1. Okay. Over a V1 is already given, that is 5 meter per second. Then what about A2? A2 എന്ന് പറയുന്നത് a total area, എല്ലാ ചെറിയ ഓപ്പണിങ്സിനും കൂടിയുള്ള ടോട്ടൽ ഏരിയ. ഓക്കെ, ഇവിടെ A2 ഇപ്പം ആ ചെറിയ ഓപ്പണിങ്ങിന്റെ ഏരിയ റേഡിയസ് R2 ആണെന്നിരിക്കും. ചെറിയ ഓപ്പണിങ്ങിന്റെ റേഡിയസ് R2 എന്ന് പറയുന്നത് 1.5 മില്ലിമീറ്റർ ആണ്. നമ്മൾ മീറ്ററിലേക്ക് കൺവേർട്ട് ചെയ്യുമ്പോൾ 1.5 into 10 raised to negative 3 meter. ഞാൻ R1 കൂടെ ഇവിടെ ജസ്റ്റ് നോട്ട് ചെയ്യാം. that is 1 centimeter. that is when converted into meter we have 10 raised to negative 2 meter. ഓക്കെ, അപ്പൊ ഈ ഒരു ചെറിയൊരു ഓപ്പണിങ്ങിന്റെ റേഡിയസ് ആണ്. അങ്ങനെ 25 ഓപ്പണിംഗ് ഉണ്ട്. ഇവിടുത്തെ A2 എന്ന് പറയുന്നത് അങ്ങനെയുള്ള ഓരോ ഓപ്പണിങ്ങിന്റെയും ഏരിയയുടെ ടോട്ടൽ ഏരിയ. അപ്പം 25 into 25 ഓപ്പണിംഗ് അല്ലേ ഉള്ളൂ. അപ്പൊ 25 into pi r2 square. that is 8. ഓക്കെ, അപ്പൊ 25 into 3. pi ഇവിടെ കടന്നു 3.9 തന്നെ വേണമെന്നില്ല. തൽക്കാലം നമുക്ക് പൈ എന്നുള്ളത് തൽക്കാലം the 25 into pi into what is R2? 1.5 into 10 raised to negative 3. 1.5 into 10 raised to negative 3 whole square. ഓക്കെ, അപ്പൊ ഇത് തൽക്കാലം കേട്ടോ, നമുക്കത് അവസാനം കാൽക്കുലേഷൻ കംപ്ലീറ്റ് ചെയ്യാം. ഓക്കെ, അപ്പം നമുക്ക് സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്താലോ. സോ A1 V1 is equal to A2 V2. therefore നമുക്ക് കാണേണ്ടത് V2 അല്ലെ. സോ V2 is equal to A1 V1 divided by A2. നമുക്ക് സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യാം. what is A1? A1 is equal to pi into 10 raised to negative 2 whole square. what is V1? V1 is 5 meter per second. and what is A2? A2 is equal to 25 into pi into 1.5 into 10 raised to negative 3 whole square. ഈ പൈയും ഇവിടെ ക്യാൻസൽ ചെയ്തു. ഇവിടെ 5 ഇവിടെ 5 ഇവിടെ 5 ടൈംസ് പോയി. ഇവിടെ നമുക്ക് വരുന്നത് നോക്കൂ, 10 raised to minus 2 എന്നുള്ളത് സ്ക്വയർ എടുത്ത് നോക്കാൻ negative 4 സ്ക്വയർ ആണ്. 5 into അടുത്തത് ഇതിനെ സ്ക്വയർ ചെയ്യുമ്പം 2.25 into 10 raised to negative 6. okay, so after the calculation you can see that the velocity at the opening, very narrow opening, is 8.88 meter per second. 8.88 meter per second. okay, Then move to the next one. The radius of a pipe decreases from 5 cm to 3 cm. If the velocity of water at the wider portion is 7 meter per second, calculate the velocity in the narrow portion. Again, we have a pipe of known area of cross section. Okay. Here, the radius of the pipe decreases from 5 cm to 3 cm. Well, here we have R1, radius is corresponding velocity V1, and this is the narrow portion. Let us take as velocity V2, radius is R2. So let us substitute. Let us apply the equation of continuity. Okay. So before that, let us R1 is taken as 5 centimeter. Keep it as a centimeter. So we have a ratio. So that will cancel out. So and R2 is the narrow portion radius, that is equal to 3 centimeter. And here we have the wider portion, the velocity is 7, that is V1 is equal to 7 meter per second. And we are asked to find the velocity at the narrow portion. Okay, so let us substitute the equation, apply the equation of continuity. A1 V1 is equal to V2 V2. So we are asked to find the V2. So A1 V1 divided by A2. Okay. Now let us substitute. So what is A1? That is pi R1 square. So pi, what is R1? 5. Okay. So 5 square into V1, 7 meter per second, divided by, what is A2? Pi R2 square. Pi R2, what is R2? 3. 3 square. Okay. That is pi will be cancelled out. That is, we can write 5 by 3 whole square into 7. So after the calculation, you will find the velocity at the narrow portion is 19.4 meter per second. 19.4 meter per second. Okay. There is one more problem. The diameter of a water pipe decreases from 15 centimeter to 7 centimeter. The velocity at the wider portion is 5 meter per second. Calculate the velocity at the narrow region. This problem is similar to the previous one. Here we have given the diameter instead of radius. So the narrow, we have a wider portion. That is, the radius is R1 is equal to D1 by 2. So the diameter is 15 centimeter by 2 centimeter. Now what about the narrow region? The radius is D2 by 2, that is 7 by 2 centimeter. Okay, keep it like this. And the velocity at the wider portion, that is the V1 is 5 meter per second. So again write the equation of continuity. A1 V1 is equal to A2 V2. Therefore, V2 is equal to A1 V1 divided by A2. So that is equal to pi R1 square V1 divided by R2 square. Pi will be cancelled out. So that is equal to R1 by R2 whole square into V1. So let us substitute. What is R1? That is 15 by 2 R2 7 by 2 whole square into V1 is 5 meter per second. So after the calculation, you can see that that is the velocity at the narrow portion is 22.96. That is supposed to be equal to 23 meter per second. 23 meter per second. Then we have the next problem. Water flowing through a garden hose of diameter 4 centimeter fills a 50-liter pond in 35 seconds. what is the speed of the water leaving the end of the hose? You can read once again. Water flowing through a garden hose of diameter 4 cm fills a pond of 50 liter in 35 seconds. What is the speed of the water leaving the end of the hose? Okay, here we are given the flow rate. Okay, നമ്മുടെ garden hose കൂടെ 50 ലിറ്ററിന്റെ പോഡ് എത്ര സമയം കൊണ്ടാണ്? 35 സെക്കൻഡ് കൊണ്ടാണ്. സോ വാട്ട് ഈസ് ദ ഫ്ലോ റേറ്റ്? ദ ഫ്ലോ റേറ്റ് ഈസ് ഒരു സെക്കൻഡിലെ എത്ര ലിറ്റർ എത്ര വോളിയം ആണ് ഫിൽ ചെയ്തിരിക്കുന്നത്. ദാറ്റ് ഈസ് ദ ഫ്ലോ റേറ്റ്. ഓക്കെ, സോ ബിഫോർ ദാറ്റ് ലെറ്റ് us write the value diameter d is equal to 4 centimeter, and from that radius r is equal to, you can see, 2 centimeter, and it is equal to 2 into 10 raised to negative 2 meter. Now the flow rate is the volume flow rate. The volume flow rate, is എത്രയാണ്? ഇപ്പോൾ 35 സെക്കൻഡിലാണ് 50 ലിറ്റർ. അപ്പോൾ ഇവിടെ എത്ര വരും? ഒരു സെക്കൻഡിലാണെങ്കിൽ 50 ലിറ്റർ ഡിവൈഡ് ബൈ 35 മീറ്റർ പെർ സെക്കൻഡ്. നമുക്ക് എന്തിലേക്ക് മാറ്റേണ്ടി വരും? മീറ്റർ ക്യൂബിലേക്ക്. ദാറ്റ് ഈസ് ദ യൂണിറ്റ് ഓഫ് വോളിയം. അപ്പോൾ 1 ലിറ്റർ എന്ന് പറയുന്നത് എത്രയാണ്? 10 raised to negative 3 മീറ്റർ ക്യൂബാണ്. അല്ലെങ്കിൽ തിരിച്ച് പറയുകയാണെങ്കിൽ 1000 ലിറ്റർ ആണ്. 10 raised to 3 ലിറ്റർ ആണ് 1 മീറ്റർ ക്യൂബ്. ഈ കൺവേർഷൻ ഓർത്ത് വയ്ക്കാം. അപ്പോൾ 50 ലിറ്റർ നമ്മൾ മാറ്റുമ്പോൾ എന്ത് വരും? 50 into 10 raised to negative 3 divided by 35 മീറ്റർ ക്യൂബ് പെർ സെക്കൻഡ്. ഓക്കെ, നമ്മൾ കാൽക്കുലേറ്റ് ചെയ്യുമ്പോൾ നമുക്ക് ഫ്ലോ റേറ്റ് കിട്ടുന്നത് 1.43 into 10 raised to negative 3 meter cube per second. This is the flow rate, volume flow rate. അപ്പോൾ നമ്മൾ ചോദിച്ചിരിക്കുന്നതാണ്, what is the speed of the water leaving the end of the hose? We know the flow rate is equal to A into V, അല്ലെ? area into area cross section into velocity. So the flow rate, area into an area of cross section into velocity is equal to a volume flow rate. Okay, അപ്പോൾ ഞാനൊന്നുകൂടി ചുരുക്കി, A into P is equal to volume flow rate. അപ്പോൾ അത് നമുക്ക് എന്ത് കാണണം? നമുക്ക് V കാണാം, വെലോസിറ്റി കാണാം. ദാറ്റ് ഈസ് V is equal to volume flow rate divided by area of cross section. Area of cross section. Okay, അപ്പോൾ നമുക്ക് ഇതിലൊന്ന് സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്താലോ? What is the area? What is the volume flow rate? That is, നമ്മൾ already calculate ചെയ്തിട്ട് 1.43 into 10 raised to negative 3 whole divided. What is area cross section? Pi. ഹോസിന്റെ റേഡിയസ് നമുക്കറിയാം, 2 into 10 raised to negative 2 meter ആണ്. So the area cross section is pi r square. So that is equal to 1.43 into 10 raised to negative 3 whole divided by 3.14 into 2 into 10 raised to negative 2 whole square. Okay, not whole square, 2 into 10 raised to 2. So you can do the calculation, and you can find that the velocity is equal to 1.14 meter per second. 1.14 meter per second. Okay. Now, another one. Find out the velocity of the water if we connect a nozzle of diameter 2 centimeter at the end of the hose in the above problem. അപ്പോൾ നമ്മൾ നേരത്തെ പറഞ്ഞ പ്രോബ്ലത്തിൽ ആ ഹോസിന്റെ ഒരു അറ്റത്ത് നമ്മളൊരു നോസിൽ പിടിപ്പിക്കുകയാണെങ്കിൽ ആ നോസിന്റെ ഡയമീറ്റർ എത്രയാണ്? 2 സെന്റിമീറ്റർ ആണ്. നോസിന്റെ ഡയമീറ്റർ 2 സെന്റിമീറ്റർ ആണ്. അങ്ങനെയാണെങ്കിൽ നമുക്ക് ആ സമയത്ത് അതിന്റെ വെലോസിറ്റി എത്രയായിരിക്കും? Okay, but again, we can use the we know A into E is equal to the volume flow rate. The volume flow rate. Okay. ഇവിടെ ഞാൻ തൽക്കാലം A2 രണ്ടാമത്തെ ഒരു പോയിന്റ് ആണല്ലോ, ഗാർഡൻ ഹോസിന്റെ അറ്റത്ത് ഒരു ന്യൂസ് പിടിപ്പിക്കുകയാണ്. അപ്പൊ ഞാൻ A2 V2 എന്ന് കൊടുക്കാം. A2 V2 is equal to the volume flow rate. അതിൽ നിന്ന് നമുക്ക് എന്ത് കാണണം? V2 കാണാം. So V2 is equal to the volume flow rate divided by area of cross section. അല്ലെ? A2 ഞാൻ തൽക്കാലം A2 എന്ന് എഴുതാണ്. അല്ല നമുക്ക് what is the diameter? അപ്പോൾ R2 എന്തായിരിക്കും? We are given D2 is equal to 2 centimeter. Therefore, R2 is equal to 1 centimeter. That is equal to 1 into 10 raised to negative 2 meter. Okay. അപ്പോൾ നമുക്ക് സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്താലോ? വോളിയം ഫ്ലോ റേറ്റ് നമ്മൾ നേരത്തെ കണ്ടിട്ടുണ്ടോ? The volume flow rate is 1.43 into 10 raised to negative 3. അപ്പോൾ ഇതാണ് വോളിയം ഫ്ലോ റേറ്റ്. ഓക്കെ, 1.43 into 10 raised to negative 3. അപ്പോൾ അത് കൂടെ കൊടുക്കാം. 1.43 into 10 raised to negative 3 divided by area cross section pi 3.14. What is the radius? R2. R2 is equal to 10 raised to negative 2 R2 square. Okay, അതാണ് കാൽക്കുലേറ്റ് ചെയ്ത് നോക്കൂ. So after the calculation, you can find that the velocity that is nozzle is 4.55 meter per second. 4.55 meter per second. Okay. We have the last problem. I think it is a very lengthy problem. Let's read first. An incompressible coil of density 850 kilogram per meter cube is pumped through a cylindrical pipe of differential cross section at a rate of 10 liters per second. The first section of the pipe has a diameter 8 centimeter. The second section of the pipe has a diameter 4 centimeter. So, what are the flow speed and mass flow rate in the first section? And also, what are the flow speed and mass flow rate in the second section? Okay, so we have a area. We have a tube of a pipe of cylindrical pipe of known area of cross section. Different area cross section. So we have in the first section. There is a first section. There is a second section. We have a diameter, different diameter. Corresponding, we have a area cross section, and correspondingly, let us the velocity we can denote the V1. Similarly, second section, the velocity and the area cross section V2 and A2. Okay. Now, here the flow rate is given. The volume flow rate is already given. Okay. So let us first write the volume flow rate. The volume flow rate that is equal to 10 liters per second. So we can convert it to meter cube per second. That is 10 into 10 raised to negative 3 meter cube per second. That is equal to 10 raised to negative 2 meter cube per second. Now this is the flow rate. Okay. Now let us try. Let us first we move to the. Okay, let us write the two radius. That is the first section. We have a radius that is R1 is equal to D1 by 2. That is, what is D1? D1 is 8 centimeter by 2. That is 4 centimeter. That is equal to, let us convert into meter. That is 4 into 10 raised to negative 2 meter. Okay. Similarly, in the second section, the radius R2 is equal to the diameter by 2. That is D2 by 2. That is 4 centimeter by 2, that is we have a 2 centimeter, that is equal to 2 into 10 raised to negative 2 meter. Now let us consider the entire first section. For the first section, the product of area cross-sectional velocity, that is A1 into V, equal to flow rate, volume flow rate. The volume flow rate. So therefore, the velocity, the speed V1 is equal to the volume flow rate divided by A1. A1. So what is A1? Pi R1 square. Okay. So the volume flow rate is 10 raised to negative 2. Here, that is pi R1 square. So that is equal to 10 raised to negative 2 all divided by 3.14 into, what is R1? 4 into 10 raised to negative 2. 4 into 10 raised to negative 2 square. Okay. So after the calculation, you can do the calculation. So after the calculation, you can see that the velocity at the first section is 1.99 meter per second. 1.99 meter per second. Okay. Now let us consider the second section. Similarly, we can have write the area cross section of the velocity. That is A2 V2 is equal to the volume flow rate. Similarly, V2 is equal to volume flow rate divided by area of cross section, that is A2. Okay. So that is equal to 10 raised to again 10 raised to negative 2 divided by pi R2 square equal to 10 raised to negative 2 all divided by 3.14 into 2 into 10 raised to negative 2, that is R2 square. Again, you can do the rest of the calculation, and then you can see that the velocity at the second section is 7.96 meter per second. 7.96 meter per second. Okay. Now we have we have to also find the mass flow rate. Here the beginning of the problem, we have the oil. The fluid is oil, and it's incompressible oil of density 850 kilogram per meter cube. Okay. So for the streamline flow, we should understand that for the streamline flow, the volume flow rate and the mass flow rate are the constants because the oil is incompressible. Okay. So for this streamline flow, we can see that the volume flow rate and the mass flow rate are the constants. Okay. So therefore, the mass flow rate എന്ന് പറയുന്നതായിരിക്കും അതൊരു കോൺസ്റ്റന്റ് ആയിരിക്കും. അപ്പോൾ നമുക്ക് ഡെൻസിറ്റി അറിയാമെങ്കിൽ what is the mass? Mass equal to the density into the volume. You know, density is equal to mass by volume. So mass equal to density into the volume. Okay. But here, therefore, the mass flow rate. Therefore, the mass flow rate ഒരു സെക്കൻഡിൽ ഫ്ലോ ചെയ്യുന്ന ട്രാൻസ്ഫർ ചെയ്യുന്ന മാസ് അതെങ്ങനെ നമുക്ക് കാൽക്കുലേറ്റ് ചെയ്യാം? ഡെൻസിറ്റി ഓഫ് ദി ഓയിൽ into the volume flow rate. Okay, we know density is equal to mass by volume. Therefore, mass equal to density into volume. We also density for oil into volume flow rate. Well, let us substitute what is the density. Density is equal to 815 kilogram per meter cube into what is the volume? Volume flow rate. 10 raised to negative 2 meter cube per second. So what is the final answer? 850 into 10 raised to negative 2, that's equal to 8.5. What is the same mean? കിലോഗ്രാം പെർ സെക്കൻഡ്. അപ്പോൾ ഒരു സെക്കൻഡിലെ 8.5 കിലോഗ്രാം ആണ് ലിക്വിഡ് ഓയിലൂടെ ഫ്ലോ ചെയ്യുന്നത്. ഓക്കെ, അപ്പോൾ ദാറ്റ് ഈസ് ദ മാസ് ഫ്ലോ റേറ്റ്.